Okay, so picture this. You walk into a toy store,
Huh?
you pick up one of those little cactus toys, or maybe it's a talking tomcat. You know the ones I'm talking about, right?
Oh, yeah, I know exactly the ones. You say something and it just carrots it back in that squeaky voice.
That's the one. And it seems simple, just a cheap plastic toy. But what if I told you that this silly little cactus is actually a symptom of something much bigger, a sort of existential crisis for engineers?
That's a heavy way to start, but I think I know where you're going with this. That our inability to make that simple toy ourselves says something about us.
Exactly. That we're not truly independent. And this gets to the heart of what we're looking at today. It's the difference between knowing how to code and knowing what to build.
Right. And our source material for this is just fascinating.
It really is. We're digging into 2 recordings of an introductory lecture for the IPD. That's the Intelligent Product Design Certificate Program at CIPD at IIIT, Delhi.
Pretty prestigious program.
And the lecturer is a guy named Dr. Dhananjay Gadre from NSUT, the Netaji Subhas University of Technology.
And Dr. Gadre, for anyone who doesn't know, is not your typical academic. He's passionate, a little provocative.
He really is. He believes in what he calls first principles engineering. He's not interested in just teaching people to follow a spec sheet.
No, he wants to know why a country like India, with some of the best software minds in the world, is still stuck in what he calls a service mindset.
He has this one quote that just it floored me right at the start. He says, "Our cream solves the problem of America. It solves the problem of Michigan. It doesn't solve the problem of Meerut."
And that is the whole episode right there. Solving for Meerut, not Michigan. It's about building for your own context instead of just, outsourcing your brain to Silicon Valley.
So let's unpack that. And we have to start with that mimicking toy.
The talking Tom.
Yeah. Dr. Gadre brings this thing into class, shows it to the students, and of course they love it. But then he asks this really sharp question. He calls the flood of these foreign-made toys East India Company Part 2.
Wow. That is a loaded historical reference.
It is. His point is, if we're just importing these little plastic black boxes because we don't have the confidence to build the simple electronics inside, are we really free?
Or are we just consumers of someone else's thinking?
Exactly. And he proves it's not a skill issue. He had his students reverse engineer it. They built a lab version with a proper microcontroller, external memory. The works.
A better version, technically.
Way better. But here's where the real lesson is. To make it cheap, you have to get into the physics of audio sampling.
The Nyquist rate. This is basic engineering stuff that it's everything when it comes to cost.
Right. Dr. Gadre explains you only need about 3.3 kilohertz for speech to be intelligible. You don't need, hi-fi music quality.
No, you're not building a Spotify speaker, so you can slash that data rate, which means you need cheaper memory, cheaper chips.
And to handle that data without any stuttering, he talks about the ping pong buffer. I loved his analogy for this.
Oh, the bucket analogy. It's so good.
Yeah. He says, imagine you're moving water from a tap to a tub. If you only have one small bucket, you fill it, run, empty it. But water is spilling from the tap while you're gone. You're losing data.
Because the recording doesn't stop just because you're busy.
Right. So you need 2 buckets. One is under the tap filling up while you're running to empty the other. You switch back and forth. Ping pong, ping pong.
And that's how you get continuous audio without needing a huge, expensive processor. But here's the kicker. The students built this amazing lab version.
Yeah.
But the commercial one, the Chinese one, it uses a single blob chip. That black epoxy blob on a circuit board.
Chip on board, yeah.
It costs pennies. The lab version costs way, way more.
And that's the whole Meerut versus Michigan problem in a nutshell, isn't it? We can build the fancy high-tech version. We have the skill.
But we aren't building the version that actually sells in a market in Meerut because we're not designing for volume. Which brings us to his next example, the roadside blinker.
Oh, the cat's eyes. You see them on highways, blinking red at night.
Right. So Dr. Gadre breaks it down. What do you need for this to work? You need a sensor for when it gets dark.
A charger for the battery.
A booster to get the voltage high enough for the LED. And a blinker circuit.
So in an engineering class, you'd think, okay, that's 3, maybe 4 different integrated circuits.
That's the textbook way. But then he pulls up the data sheet for this one Chinese chip, the QX5252.
And it does all of that in one tiny package.
And the cost. It's just wild. He said it's 8 rupees.
8 rupees, that's what, 10 cents?
Something like that. And that's the retail price here after import duties.
So the manufacturing cost is probably half that. It's insane.
How is that even possible?
Volume. It's always volume. He does the math with the students. India has 60 lakh kilometers of roads. You put one blinker every 10 meters.
That's a huge number. It's 600 million units. 60 crore. When you're making 600 million of something, you don't just patch together 3 generic chips.
You design one custom chip that does everything perfectly.
And his critique is so sharp. He asks, why didn't an Indian engineer think to combine those 3 functions? It's not that we couldn't, it's that we weren't thinking about the scale of the problem.
We're thinking like circuit designers, not product designers.
Exactly.
And sometimes the reason we don't do these things isn't even about volume. It's about just inertia. He shows off this prototype he built, a battery-less TV remote.
This is one of my favorite examples of his. It's just brilliant, sustainable engineering.
It's so cool. He just takes a normal remote, guts the battery part, and puts in a little tube with a magnet and a coil. You shake it a few times, and it charges a capacitor. Faraday's law.
It's a tiny linear generator. Shake it, store the charge. No more AAA batteries. Ever.
And he did the math. Just for a city like Delhi, TV remotes create about 20 tons of battery waste a year.
20 tons of toxic chemicals leaking into landfills.
And this remote solves that. So why isn't it in every store?
That's the million-dollar question, isn't it?
And the answer is kind of depressing. It's the status quo.
Newton's law of inertia, but for business. Manufacturers make money selling replacement remotes. Duracell makes money selling batteries.
And let's be honest, we're lazy. We don't want to shake a remote. We just want to push the button.
Dr. Gadre says it might need government intervention, like emission standards for cars, maybe e-waste standards for electronics.
It just shows that engineering isn't a vacuum. It's tied to psychology, economics, even politics.
For sure. And speaking of how engineering is done, we have to talk about the module trap.
Ah, yes, the Arduino culture, as he calls it.
Right. So he lays out his 6-box model for any electronic product. It's input, output, processing.
Power supply, communication, and storage. And then the glue electronics holding it all together.
It's a great mental model. But his problem is that students, and even some pros, are just buying pre-made modules for each box. Need a sensor. Buy the sensor module.
He calls it Lego engineering. You just snap the blocks together. I mean, it works, so what's the problem?
The problem is your moat, your competitive advantage. If you build your product with off-the-shelf Chinese modules, what's stopping your competitor from buying the exact same modules?
Nothing. You have no secret sauce.
0. To build a real product, you have to go deeper, to the component level. You can't just use a motor driver module. You have to understand how an H-bridge actually works.
He got into the details on that high-side versus low-side switching.
It's so important. To make a loader go forward and backward, you need switches on both the high side, near the power, and the low side, near the ground. And you can't treat it like a black box.
Because if you do, you're wasting power, creating heat.
Or just blowing up your circuit. And cost. A module has the module maker's profit built in. Designing it yourself with the raw components is always cheaper at scale. That's the difference between a prototype and a product.
It's about owning the IP. If you know how the electrons are flowing, you own it. If you just know which pins to connect, you're just an assembler. Okay, we have to talk about my favorite demo of his, the magic candle.
Oh, this one is a brilliant bit of lateral thinking.
So he's got this electronic birthday candle, an LED, but you can actually blow it out, like a real candle.
And the puzzle is, how does it know you're blowing on it?
My first thought was a microphone, right? It hears the whoosh.
But then, if you clap your hands at the party, the candles all go out. That's no good.
True. Okay, so maybe a tiny wind sensor.
Too complex, too expensive, it would break.
So what is it?
A thermistor, a simple temperature sensor.
A temperature sensor. Wait, but your breath is warm. If I blow on my hand with my mouth open, that's warm air.
Right, but do you blow out a candle like that? With your mouth wide open?
No, you purse your lips, like, whoo.
Try that on your hand.
Oh, whoo.
Oh, okay, that feels cold.
That's physics, Bernoulli's principle. When you force air through a small opening, it expands and cools down.
So the chip isn't looking for wind. It's looking for a sudden drop in temperature, a negative slope, a negative trip. If the temperature plummets, it knows someone just blew on it with pursed lips.
That is it's genius, using simple physics to solve a sensing problem with a cheap part.
But, and there's always a but with Dr. Gadre's stories, the product failed.
What? Why? It works perfectly.
He tried to sell the idea to a baker. He said his prototype cost 500 rupees to make.
Oh.
The baker just laughed at him. He said, the cake costs less than 500 rupees. Who is going to buy a candle that costs more than the cake?
Ouch. That's a painful lesson.
The lesson is, don't price your product based on your prototype. He was thinking like a lab engineer, what it cost him to make one. He wasn't thinking about what it would cost to make 1,000,000 in Shenzhen.
If he had calculated the volume cost, maybe 50 rupees, he might have had a business.
He was thinking too small. He was thinking like a hobbyist, not an industrialist.
That seems to be the central theme, doesn't it? Thinking at scale.
And that leads to his final and maybe most provocative point. He asks the class, why hasn't India, with the most programmers in the world, produced a global operating system?
He calls them software slaves, which is harsh.
It's very harsh, but he's trying to wake them up. His point is, we know how to program. We can execute a spec flawlessly, but we don't know what to program. We lack the product vision.
We're building the bricks, but someone else is designing the cathedral.
Perfectly put. We're solving the problems of Michigan, not Meerut.
So, for anyone listening to this, if you're an engineer, a student, a maker,
Yeah.
what's the big takeaway here?
Get your hands dirty. Dr. Gadre calls the book The Art of Electronics the Gita of electronics.
Sleep with it under your pillow.
He means it. You have to internalize the fundamentals, the transistor, the resistor, the physics. You can't just live in the world of high-level code and modules.
And think about volume from day one. Don't build for one, build for 1,000,000.
And solve a real problem. Look around you. The world is filled with wasteful, unoptimized systems just waiting for an intelligent product design.
So the question he leaves everyone with is, are you going to keep taking specs from someone else? Or are you going to build something new for your own world?
It's the difference between building a project in a lab and building an industry.
That's it for this deep dive. We hope this sparked some ideas.
Go break some modules. Build something real.
See you next time.